Alright, so we're given a double roadmap problem here. 1.34 times 10 to the 23rd atoms of oxygen, and asked to convert that to titanium 4 oxide. So we're going to convert this mole problem. How do I set up every single mole problem? What do I have to do? Come on, you know it. You know it. Sitting there at home, you know it. What am I supposed to do?
Start with what you're given.
What I'm given over 1. So I'm going to start with what I'm given here over 1. Don't be lazy. I'm telling you. Don't be lazy. And not put in atoms of O, because that is your director. It's going to tell you where you're going. So I'm in atoms of oxygen over 1. What's my next step? What do I need to do here? What do I always have to do?
Put the atoms of oxygen on the bottom.
Atoms of O down here. You don't have a choice. Whatever's on top goes down to the bottom automatically. Now here's something you might not know, if you haven't realized it yet. When you have atoms of oxygen, when you're on the bottom, if you look over here at our map, that's where you are at on the map. So I'm in atoms of an element, so element track, I'm in atoms. So I'm in atoms. When I'm on the bottom, that's where I'm at. Where I'm going to, where does that go?
On top.
On top. So where I'm going to goes on top. So I'm going to moles of an element. So I put on top moles of an element. I'm in oxygen, right? What always goes with mole?
1.
1. Now, atoms. O. If you look on your map, this side, the A side, atoms, ions, what number do I use here?
6.02 times 10 to
You
the
got it.
23rd.
6.02 times 10 to the 23rd atoms are in 1 mole of oxygen. This allows my atoms to cancel. I'm in moles. Next step, whatever I have, it comes right down here. I do not have a choice in that. Again, when I'm on the bottom, that's where I'm at on the map. So where am I going now?
To down the mole
Down
ratio.
to moles of a compound.
Yeah.
So where I'm going goes on top. I'm in moles of an element. Where I'm going, moles of a compound,
It goes on top.
goes on top. So I just put moles of a compound. What compound? Well, the one I was asked to find, TiO2. This is that new thing, that mole ratio. Mole ratio. It's the number moles of an element per 1 mole of the compound. So right here, what goes with my compound?
1.
1. What goes with my O's? How many O's are in TiO2?
2.
2. So it's 2 moles of oxygen. Allows me to cancel my moles. I'm now in moles of a compound. What's my next step?
Oh, put moles on the bottom.
Moles on the bottom. Whatever you have here goes down here. Again, I'm on the bottom. That's where I'm at on my map. Where I'm going. Am I going left or am I going right? What's my problem asked me to get?
Grams.
Grams. So I want to go left. So where I'm going goes on top. Grams of a compound. TiO2. What always goes with mole?
1.
1. Molar mass of the periodic table. So my grams here, I need to put here molar mass of TiO2. Where do I find that at?
Periodic table.
Periodic table. Grab one of these, right? Add up Ti on your handy dandy calculator. We get 79.88, right?
Yep.
Make your final cancellation. And I'm in grams TiO2. That's what I want to find. What do I do here? Multiply or divide?
Divide.
Divide, then
Divide.
divide again, and
Multiply.
multiply. So I'll punch this in my calculator real quick, and we get 8.89 grams of TiO2 as your answer. Write down this example. We're good.